Now, when you're solving systems of equations, it's also possible to get things like no solutions in identities, or the idea that everything is a solution as well. So let me show you one of those examples and what to watch out for. So the first thing I'll do is I'll just share my screen to show you the example that I want to work on here. So here's my example. So here are my two equations. This one's solved for y already. This one isn't, which is fine. Doesn't matter which way the equations are given to you. And I'm going to start by graphing first. And we're going to see actually that this is going to be an example of a no solution problem. Excuse me, my throat is very dry today. I apologize. So there's the first equation. And here's the second one. I think I have to zoom out a little bit. X minus y equals 6. And I'm going to just correct this. Let's go from negative 10 to 10, and same thing on the y-axis. So we'll just kind of start in that standard grid. All right, so here are my two graphs. They don't look like they're intersecting. Even if I keep zooming out, I'm not seeing any intersections, right? So if you actually look here, they actually are parallel lines. So they're never going to intersect. So when I look at the graph, I'm just making a little note here. If they never intersect, they are in fact parallel lines. And remember, parallel lines have the same slope. So that's how you can tell by looking at the equations, they'll have the same slope. And something like this is a no solution. Okay. Now you do want to be careful. So I know I've graphed it, and I said graphing is a good way to start or check, but it shouldn't be the be all and end all. It looks like they're parallel, but what if they were slightly off? What if one slope was like 2 and the other slope was 2.0001, right? I wouldn't see that graphically. My brain probably wouldn't be able to comprehend that they will eventually intersect. They would look the same. So you do want to check algebraically. So what happens is if you're using substitution, excuse me. All right, sorry about that little blip. So let's talk about substitution here. So when we're doing substitution, we're solving for one equation for one variable. Now, in this case, I'm going to just start with this because this equation is already solved, which is really nice. So I'm not going to resolve anything here. I'm going to start with the equation that's already solved. And then I'm going to go ahead and plug that into my other equation. So notice here, you're solving for y. So I'm going to replace y over here. So I end up with x minus, just be careful, you're distributing that minus sign. So I'm plugging in the x plus 4 equals 6. And you get x minus 4 equals 6. Well, x minus x cancels, so I'm left with negative 4 equals 6. And you can see this is a false statement. Just like we do when we solve equations, if you get a false statement, it's a no solution. So here's what would happen for substitution. You would solve for the equation, go to plug it in, everything seems normal, but once you start solving again, it just doesn't work. You get a false statement. So again, you have no solution. So now I know for sure that truly these are not going to intersect. You can also see it with elimination. Now here I do have a little bit of work to do. So when you're doing elimination, we do like to have our variables on the same side. So I do have to bring this x over. So it's going to be negative x plus y equals 4 instead. And now I'm going to put them on top of each other. And when you go to add them together here, I don't have to multiply anything because one of my variables already cancels, right? The x's cancel. So I don't have to multiply here, which is nice. The y's also cancel, and I'm left with 0 equals 24. And again, it just doesn't work. You get another false statement. So this is what's going to happen with elimination or with substitution, is you're going to somehow trickle down to a false statement in the end. It may not be as obvious right away, so sometimes you may still have to multiply, you may have some solving to do, it may look like a totally normal problem, but as you go through, you're going to see that there's just issues with it, and it's not going to work. And basically, like I said here, what happens is if you check the slopes and put these both in that y equals mx plus b form, you'll see they both have a slope of 1. So they're never going to intersect in this case, because they have different starting points. One starts at 4, one starts at 6 on the y-axis, and the same slope. So they won't intersect. It is also possible to get infinitely many solutions. Okay, so here's a system that actually would have infinitely many solutions. And basically what happens is the only reason it has infinitely many solutions is because you have the same exact line. If you try to graph this, and we can show that real quick here. Go to Desmos. So I use the first starting equation will be the same, and then we'll do 2y equals 2x plus 8, and you'll see that one line goes right on top of the other line. So you actually have the same line here. When you have the same line, and it's exactly the same, right? This is not just the same slope, but the same slope, the same y-intercept, it's the whole thing that's the same. Then you end up with infinitely many solutions. So again, when you graph it, what happens is you end up with that same line. But you can also check by substitution and by elimination. So if you're checking by substitution, again, this line is already solved for y equals, so I'm just going to go ahead and plug it in. So I would have 2 times, I'm going to take, so I'm plugging into here, that x plus 4 piece. And I distribute, and I see that I get 2x plus 8 equals 2x plus 8. Obviously, those are the same. If you keep solving, if you subtract 2x from both sides, you still get 8 equals 8, which is a true statement. So when you get that true statement and your variables cancel, you have infinitely many solutions. So you see it there with substitution. And you can also see it there with elimination as well. Okay, first thing I do have to get all the variables to the same side. So I'm going to just bring my x's over. So it'll be negative x plus y equals 4. Here again, you're subtracting it. So negative 2x plus 2y equals 8. And then we put it on top of each other. I do have a little bit of work here. I think if I multiply this first one times negative 2, that will work. So I would get positive 2x minus 2y equals negative 8. Negative 2x plus 2y equals 8 would stay. So I'm just changing that over. Notice that my x's now cancel. But my y's also cancel, and I'm left with 0 equals 0. Now, this is a true statement, not false. 0 equals 0 is true. So again, you would have infinitely many solutions here. And these exceptions are not going to come up too much. I mean, you will see them occasionally, particularly elimination. Particularly infinitely many solutions, excuse me. In the real world, that really isn't going to come up because you have the same line twice is what's happening. But we do sometimes see no solutions if we're trying to graph things and those graphs are just not intersecting. They have the same slope. But more often than not, there probably is some solution there. So as you're going through the questions, be on the lookout for these more extreme answers of no solution or infinitely many solutions, but know that probably most of your answers will have some sort of actual numerical solution.